Howdy, AP PreCal. It is Miss Kosh. Today we want to look at trig equations and inequalities. So I taught this last year, and I'm changing it up this year. So I have a new way, and hopefully it makes sense. What I want to do is I want to look at this from different directions or bring in the different things that we've already talked about. So I have 4 examples. And we shall see how many of them I make it through in this first video, but then I'll come back for more. Okay, so this first one, they've given us the function f of x equals 2 sine x plus 1. Actually, I gave it to you, so whatever. I'm giving you a place to graph that, and actually, let's jump straight to there. We know that sine of x starts at the midline, goes up first, then go back to the midline, then goes down, and then back to the midline. We have an amplitude now of 2. And so we're going to go, and then we're going to be shifted up 1. So the midline is 1. So hopefully this is, I would argue it's a pretty simple transformation where, and then we're going to go up to 3, back, and then we go down to as low as -1. We come back. So there was one period. I haven't rounded it out yet. But then it said to graph it on the domain. I wanted you to go a little bit beyond that one period. And so we're here. Coming backwards, this is -1. I think each little tick mark was half. And so let's see if I can get my concavity right. We're concave up, we're concave down, we're concave up, we're concave down. And there we have graphed our function. Okay, you'll notice we're about to look at some equations and inequalities with that graph. So let's just keep going. So when it says to solve this equation, I would take 2 sine of x plus 1, and I would set it equal to 0. Then I subtract 1 and divide by 2, so sine of x is equal to -1/2. And now here's where I would solve that problem by thinking of my unit circle, which there's a lovely little box for the unit circle. Sine is the y value. I want to know when is the y value -1/2. Well, this would be 7 pi over 6. And 11 pi over 6. If anything I'm saying doesn't make sense to you, it probably means you don't have the foundation that my kids have at this point. And so go back and watch previous videos because we're really good now at the unit circle and we're really good at graphing. So I'm making the assumption that you can do both of those things also. Okay, so there's 7 pi over 6 and 11 pi over 6. So they said solve the equation on the interval 0 to pi over I lied. From 0 to 2 pi. Let's see if I can talk today. And so that means we get 1 time around the circle, and that's it. So our answers would be 7 pi over 6 and 11 pi over 6, and we're done. Okay, then we can kind of extend this to say, well, find for all real numbers. Well, you'll notice, oh, by the way, this is like, when does this graph equal 0? So that was that curve. When did it equal 0? Well, I see 1, 2, 3, 4 zeros just based on what we've drawn. So the first part was saying on the interval from 0 to 2 pi, where were our answers? Well, they were here and here. And from the unit circle, we know that this one is 7 pi over 6, and we know that this one is 11 pi over 6. But we also know that this periodic function keeps happening and happening and happening. We all, or we're thinking unit circle, we have all the coterminal angles to each of these angles. And so when it says to find all solutions, we'll say, well, x is equal to 7 pi over 6 plus 2 pi k, assuming that k is an element of the integers. My kids like to say kes. And then the other, 11 pi over 6 plus 2 pi k. So everything coterminal. Once again, k has to be an element of the integers. I would allow my kids to write kes like once per page or kind of write it as a general thing. But officially, we probably should write it every time. Okay, so now they're asking us, so we've solved the equation both on a particular interval and for all real numbers. So far, so good. Now we want to look at some inequalities. And you remember, we've done inequalities in this course. We did inequalities with polynomials, we did inequalities with rational functions, we did inequalities with exponential functions and logarithmic functions. The inequalities, AP PreCal loves them some inequalities. I don't know what just came out of my mouth, I'm sorry. But they love inequalities, and we're going to do inequalities in the trig world also. So notice these 2 problems that I wrote you. They give you a particular interval, so we're going to live in the world from 0 to 2 pi. And so when I go to do a sign diagram, I'm going to go from 0 to 2 pi. Sometimes I do dotted lines to show where it's a 0, and sometimes I don't. But 0 and 2 pi are not actually zeros of this curve. So the zeros would be 7 pi over 6. And what's the other one? 11 pi over 6 is somewhere over here. And there's the beginning of our sign diagram. That's the things we care about. I think I might need more space. So now what we can do is we can look at our graph, because from the graph we can tell it's going to go positive, negative, positive. However, sometimes we will do these problems and we won't want to take the time to graph. It doesn't tell you that you can't graph, but there are ways to do this problem without actually graphing. So let me talk through that. What I might do is take a value and say something between 0 and 7 pi over 6 that's easy to work with. How about pi over 2? That could work. It doesn't have to be pi over 2, but so then this becomes 2 times sine of pi over 2 plus 1. Sine of pi over 2, pi over 2 is as high as it ever gets, so that's 1. So this becomes 2 times 1 plus 1 is equal to 3. That is positive. There's a positive in this interval right here. Okay, then we could find something between 7 pi over 6 and 11 pi over 6. When I look back at my unit circle, 7 pi over 6, oh, that's lovely, pink and red. Ugh. Okay, but I'm looking, and I know that 3 pi over 2 would be something in that interval. Sine of 3 pi over 2 is negative 1, so this is 2 times negative 1 plus 1. That gives me a negative 1. I ran out of space. And so then I know that that interval is negative. Then I can try, well, the thing that, it's a little tricky, there's not anything unit circle friendly between 11 pi over 6 and 2 pi. Later I will teach you how to find, what would that be, 23 pi over 12, but that's kind of annoying. And so, but what we notice here is that 2 pi was not actually a 0. So we can just plug in 2 pi because what's happening bigger than 11 pi over 6 will happen also bigger than 2 pi because it kind of continues for a little while. So when I plug in 2 pi, 2 times sine of 2 pi is 0, times 2 is 0 plus 1, this is equal to 1, so that's positive over there. So I can evaluate my plus minus plus just without looking at the graph, but if I have the graph, if I know what I'm doing there, then all of a sudden it gets a lot easier. Okay, so now we can look at answering these two questions. Find the set of values where the interval, on the interval where f of x is greater than or equal to 0. Well, at 0, we were greater than or equal to 0, and we were equal to 0 at 7 pi over 6. And then we pick it up again, and we can say, well, we're still equal to 0 at 11 pi over 6, and then we can go to 2 pi, and that's the interval they asked us to live in. And so that matches what we see on the graph plus what we see on the sign diagram, but also we can look down here and think unit circle for a second. We were trying to say 2 sine of x plus 1 is greater than or equal to 0, which means that sine of x is greater than or equal to negative 1. Okay, so if we think unit circle, this is something I'm still chewing on. So I don't know if we can generalize with the unit circle on all these problems, but I think I have seen that some AP teachers use this strategy, but I'm still chewing on it. I think it works in this problem, but I don't know yet if I can generalize it to other things. Okay, so I want to find the angles whose sine value is greater than or equal to 1/2, negative 1/2. So here is negative 1/2. So notice any angles that are formed below that line, those are going to be, those will be angles whose sine ratio is more negative than negative 1/2, so less than negative 1/2. And so I want anything that's above that line. So I can start at 0 and include all the angles until here, and then the angles between 7 pi over 6 and 11 pi over 6 won't work for us, but then these angles right here will. So does that help? I don't know. Anyway, we're going to keep playing with that and see if that makes sense for us. And, okay, so now we want to know where is f of x less than 0. Well, it equals 0 at 7 pi over 6, and then it equals 0 at 11 pi over 6, but we don't want to include those. It knows everything in between those. Hopefully, that is helpful. Okay, let's look at the next one. On this one, I have 2 cosine squared x. Oh, by the way, I don't know if we've said this yet this year, but if I take cosine of x and I take that value, so I have an angle and I take its cosine and then I square that ratio, that's one way we could write this. Mathematicians are inherently lazy, I mean efficient, and we want to use as few symbols to convey as much information as possible. We are the opposite of politicians. They want as many symbols as possible to say as little as possible. Okay, sorry. That's on all sides of the aisle. Okay, well, so what we do, here's the short answer. Instead of saying cosine x quantity squared like that, we will say cosine squared x like this. They mean the same thing. This, however, is totally wrong. If you wrote cosine x squared, what this is saying is take your angle x, square it, then take the cosine of that. We never do that. I mean, if people do it, they don't do it in my class. So it's beyond the scope of my world. So this is no good. We don't want to use that. So that is what that problem is talking about. You could do a u substitution to start solving this. Not a me substitution, but a u substitution. I could say, you don't have to, but let u equal cosine of x, and then we can rewrite this as 2u squared plus u equals 0, not me, but you. And then I can factor out, I think I'm funny, it's up for debate whether that's accurate. And so then I get down to u equals 0 or u equals negative 1/2. Well, we weren't trying to solve for u, we were trying to solve for x. So cosine of x equals 0 or cosine of x equals negative 1/2. So here's the unit circle spot for us. Where is cosine of x equal to 0? Cosine is the x value. It's equal to 0 at pi over 2 and at 3 pi over 2. Where is cosine equal to negative 1/2? This would be 2 pi over 3, and this would be 4 pi over 3. I guess I could label this as pi over 2, like I said, and this is 3 pi over 2. Okay. So what were the directions in this box? The directions were on the interval 0 to 2 pi. So x equals pi over 2. Then it equaled 2 pi over 3. If you have to put them in order, here we go. Then 4 pi over 3 was next. And then 3 pi over 2 was next. I don't know that you have to put them in order, but I did. Okay. And so then it says find for all real. That means we have all the coterminal angles to consider. And when I look at that, I notice that pi over 2 and 3 pi over 2 are pi units apart, and I'm lazy, I mean efficient, and I'm just going to say, well, let's just write one of them and say plus pi k instead of plus 2 pi k. You can write both of them plus 2 pi k. I just want to be efficient. I don't want to write more than I have to. Okay, and then the other one, 2 pi over 3 does need its own 2 pi k because those are not equally distributed. And then it's 4 pi over 3 plus 2 pi k, where k is an element of the integers. There we go. Okay, and so now we've got a bunch of different values that we need to consider on our sign diagram. And so it gets a little more complicated when we start looking at this. And this graph is something that I wouldn't expect you to do by hand, but we do know a lot of details about it. Actually, I already made my answer key. And what I started doing is I started plugging in points. And so I knew my zeros from here. Can you see a little cursor? I don't know. I knew my zeros from here. So I put them on the grid. I had a 0 at pi over 2. I had a 0 at 2 pi over 3, 3 pi over 2, 5. And then I had the one, so this is at pi over 2. This is roughly 2 pi over 3. And this is roughly 4 pi over 3. I didn't make the grid nice and neat for that, but anyway, it is what it is. And then, so it looks something kind of like that. Okay, so then what I did is, and then I could plug in at 0 and at 2 pi. Those were easy numbers to kind of work with. I think I did this right here. And I found a value of 3. But that didn't tell me as much as I wanted. So then when I graphed it, you'll see it looks something like that, which is kind of cool. Not something that I would expect you to graph by hand. But what we'll do is we'll do a sign diagram. So I came and I put the beginning and the end of that interval, so 0 and 2 pi. And then I came and I put, I should probably use dotted lines for pi over 2 and 2 pi over 3 and 3 pi over, I lied, that's 4 pi over 3 and 3 pi over 2. Those are all the zeros. So then I plugged in different values and was able to figure out what's positive and that sort of thing. It was a little trickier. There's not a good value to plug in between pi over 2 and 2 pi over 3, but we can kind of assume, and we see in that graph that it goes negative. Okay, so then when was it positive? And since this is equal, then we can use hard brackets. Where was it positive? It was positive at between 0 and pi over 2, between 2 pi over 3 and 4 pi over 3, between 3 pi over 2 and 2 pi, which we saw from our sign diagram. This is one where I can't quite just use the unit circle. Maybe I need to think about it more. If you know how to use the unit circle to find the inequality questions, then let me know. That'd be great. Okay, and then where was it less than 0? From pi over 2 to 2 pi over 3, and then 4 pi over 3 to 3 pi over 2, which we didn't quite get from our graph. Well, okay, we do know this. We do know that none of these zeros have a multiplicity of something besides 1. Or let me say that better. All of these zeros have a multiplicity of 1. So if it's positive here in each of those intervals, then it's going to have to be negative in those because it's just passing through those zeros. That we do know. I do feel comfortable with that. Okay, and then you can see when you actually graph it, sure enough, it does go below 0 there. I plotted all those little points. Isn't that fun? Okay, I am going to sign off on this video and then come back for problems 3 and 4. So like, subscribe, comment, and go practice.